Today, we're sharing 5 announcements from the research team here at Runway. Some you will expect, others you may not. They represent a big step towards our mission to advance AI systems that can simulate reality. Let's jump right into it. Our first announcement today is some updates to our latest base model, Gen-4.5. For that, I'd like to welcome Michal from our research team. Last week, we announced Gen-4.5, our newest base model and the best video model in the world. I'm happy to share that Gen-4.5 is now available to the product for all paid plans. But that was just the beginning. Today, we're introducing 3 major additions to Gen-4.5.
The first addition is native audio generation. Gen-4.5 will soon be able to generate videos with audio, including realistic dialogue, compelling sound effects, and immersive background audio, transforming the type of stories you can use this model to tell. The second update is native audio editing. Not only will you be able to generate videos with audio from scratch, but also you'll be able to edit the audio of existing videos to suit your needs. Our third addition to Gen 4.5 is the ability to edit videos of arbitrary length, applying consistent transformations across multiple shots. This is a major update for our current video editing model, Aleph, and it required solving some hard engineering and research problems. The model maintains now consistent edits of characters, lighting, and environment throughout multiple shots. Here's a video showing what this model can do. Last week, we announced Gen 4.5, our frontier video generation model, and the best video model in the world. Today, we're excited to share 3 new updates to Gen 4.5 that push the frontier forward once again. The first update we'll be bringing to Gen 4.5 is native audio generation.
They keep chanting my name, but nobody remembers my birthday.
Soon, when you generate with Gen 4.5, you'll have the ability to include native audio generation as well.
For 20 minutes.
Everything from dialogue
And we're trying to decide if we build a new one.
to sound effects and even background music.
And this is step 1!
The second update is native audio editing. Not only will you be able to generate novel videos with audio,
Tick, tick, tick.
What? No.
but you'll also have the ability to edit audio of existing videos to suit your needs.
What? No.
You can change a performance, audition new lines,
Can I go to the bathroom after this take?
and even explore multiple iterations.
That's not how this works. You can do it. Who else if not you?
Our third update is multi-shot editing. You can now edit videos containing multiple shots, videos of any length, applying consistent transformations across multiple shots. Gen 4.5 updates are coming soon.
Do you remember?
It's like a sleeping bag, but only for 1 foot. Why would they warm just 1 foot?
Relax, hero. Just follow my vision. I may not see where I'm going, but I'm never wrong about where you're headed.
Learn more at runwayml.com.
We'll be releasing these updates in the coming weeks, first to our enterprise customers and creative partners, and to all paid plans soon after. Thank you, Michal. Next up, some exciting updates on our long-term initiative to simulate the world. When we first introduced the Gen series of models, the main question we were trying to answer was whether generative AI models could be viable tools for creative expression. Could they be used to tell compelling stories, to augment human creativity? I think that question is now settled. The new question is the following: Can video models simulate physical and digital reality well enough to be useful beyond that? To answer that question, 2 years ago, we introduced a new research direction: general world models. World models are AI systems that build representations of the world and use them to simulate the outcomes of taking different actions in the world. And we think building powerful world models is very fundamental to further advancing AI. To build a world model, we first needed to build a really great video model. We believe that's the right path to building world models, that teaching models to predict pixels directly is the best way to achieve general purpose simulation. At sufficient scale and with the right data, you can build models that have a very deep understanding of how the world works. And I think we've reached the point where we're ready to share our work towards this mission. So our second announcement today is GWM1, our first general world model. Models like Gen-4.5 are built to predict an entire video at once. You give Gen-4.5 a prompt, you wait for some time, and then you get back a full video output. GWM1 is built on top of Gen-4.5, but has one crucial difference. It's autoregressive. It predicts frame by frame based on what came before. And most importantly, you can intervene at any point during the streaming generation with actions. What actions are can depend on your application. It can be moving around in space, it could be controlling a robot arm, it could be interacting with an agent. But the model takes that as input and simulates what happens next as a consequence of those actions. World models, at their core, are simulators. And we believe that they are the frontier of progress in artificial intelligence. Language models alone will not solve the hardest problems that the world faces, especially those that involve interacting and understanding the physical world, whether it's in robotics, in disease, in scientific discovery. Real progress in those fields requires models that experience the world and learn from their mistakes, the same way that humans do. And this kind of trial and error can be massively accelerated when it's done in simulation, rather than when it's done in the real world. We truly believe that world models offer the most clear path we have for general purpose simulation. One of the most natural things to simulate is an environment, a space that you can explore, you can interact with, and you can build on. Which brings us to our third announcement. This is GWM Worlds, a world model for real-time environment simulation. To go deeper into GWM Worlds, I'm joined by Ziyi, who is part of our research team behind World Models.
Thanks, Anastasis. With GWM Worlds, you can simulate an explorable space. You first describe a scene or provide an image reference, and it can generate an immersive environment that you can move through with the right geometry, lighting, and physics. The model runs in real time with 24 frames per second and 720p resolution. You can travel to any place, real or imagined. You can also become any agent. A person walking through a city, a drone flying over a snowy mountain, or a robot navigating a warehouse. What makes this all work is consistency. When you explore a real environment, you expect everything around you to stay coherent. If you turn around, and what was behind you should still be there. Walking forward and back, you should return to where you started. GWM Worlds maintains this spatial consistency across long sequences of movements. Now, this is obviously useful for fun, interactive experiences like games, worlds, immersive environment, but we think it's equally important to use it to train the agent themselves. If you want to train an AI system to navigate and act in the physical world, you need a simulator in which to teach it. GWM Worlds can serve as that simulator, where agents can explore, make mistakes, and learn.
Now let's take a closer look at GWM Worlds.
GWM Worlds is a world model for real-time environment simulation. With GWM Worlds, you don't simply generate videos of environment, you simulate them. So you can start with a static image and simple prompt, then begin to explore that complex, dynamic world, all in real time. You can walk, drive, fly, or even skydive through any world, real or imagined. GWM Worlds has accurate lighting, physics, and geometry, and it's able to maintain both spatial and temporal consistency across long sequences of movement. GWM Worlds is still in early development, but it's showing extraordinary promise for the future of real-time explorable simulations. Learn more at runwayml.com.
Really great progress. Thanks, Iggy. Moving on to our next announcement. GWM1 can simulate environments, physics, and motion. But one of the most complex things to simulate is human behavior. The way people look, the way they move, the way they respond in conversation, in a way that feels natural and immersive. And this is really difficult to get right, traditionally, for models. We think we've improved on this quite a bit with our fourth announcement. This is GWM Avatars. To talk about this more, I'm joined by Ining from our Avatars research team.
Thank you, Anastasis. Simulating human behavior is really hard because humans are very good at reading other humans. We pick up on micro-expressions, the eye movement, even the subtle ways someone shifts their weights while they're listening. Digital humans have often failed here, not because they look wrong, but because they move wrong. GWM Avatars takes a different approach here. The model is expressive, high fidelity, and offers natural responses in real time. It looks real, and it feels real. GWM Avatars is an audio-driven, real-time video generation model. It simulates natural human motion and facial expressions. The model renders the eye movement, the lip syncing, and the gestures while both speaking and listening. It runs at 720p and more than 24 frames per second for extended conversations without downgrading quality. GWM Avatar is a general model. Our avatars aren't constrained to one single character type or one visual style. The very same model simulates realistic humans and animated characters with the same fidelity. I'm very excited to share this new model with you all.
Thank you, Ining. Let's take a look at a demo.
Let's take a look at the demo. So I'm horrible at Spanish, and I really want to get better at it. I found this language tutor online called Ivy, so let's talk to her together and learn some Spanish.
Hola, bienvenido. Have you studied any Spanish before or starting fresh?
I'm starting fresh.
Perfect. Let's pretend you just walked into Cafe Luna in Madrid. I'll be the barista. Hola, bienvenido. ¿Qué te gustaría?
Hola, un café, por favor.
You did great.
Gracias.
De nada.
So I'm very good at French trivia. So let's play a French trivia game with this fluffy character. He's my favorite character. His name is Tooth.
Well, hello there. Are you ready for some fast-paced trivia fun?
Let's play the trivia game of the TV show Friends.
Ooh, a Friends trivia challenge. Excellent choice. First question. What is the job title of Ross Geller?
New York University professor.
Dramatic pause. Yes, that's correct. You've got your first point.
Cool, awesome. Also, I sometimes want to create my own avatar. So coming here, I can upload my own image here, and then I'm going to choose a voice. And then I will say, putting some instructions saying you love birthdays. I create the character. I'm going to start the call to the character.
How are you today?
I'm good. Today is my birthday.
Oh, wow. Happy birthday. That's wonderful. Happy birthday to you. I hope you have a wonderful day.
I will. Thank you. Bye. Cool. That's all our avatars. Hope you have fun playing with it.
How are you doing today?
Hello to you, too. So, what brings you here today? What's on your mind today?
From real-time tutoring to dynamic training simulations, we think these avatars will be useful for a wide variety of applications, and we're actively exploring many of them with partners. Now let's get into something we're especially excited about. A few months ago, we set out to understand exactly how our models could be useful to accelerate progress in robotics and other AI systems that interact with the physical world. We've been collaborating with some of the leading companies in the space, and we've developed an initial approach that we think is good enough that we're ready to open it up to more people, to accelerate development across the industry. So our fifth announcement for today is GWM Robotics. To talk more about GWM Robotics, I'm joined by Rick, who leads our robotics research.
Thanks, Anastasis. Training robots is expensive and slow. Data collection requires physical robots, real environments, and human supervision. It's fundamentally hard to scale. The bitter lesson in AI is that we can scale the performance of models with more compute and more data. Yet, progress in robotics remains bottlenecked by physical data collection. To go beyond real data, simulation-driven 3D engines are commonly used. Traditional simulation works well for locomotion, moving around in space, but it often struggles with manipulation accurately. Accurately simulating robots interact with diverse real-world objects is extremely complex. Instead of hand engineering physics, world models learn interaction dynamics directly from data. And crucially, world models learn from failure as well as success. Video models can often be biased towards successful outcomes. They've mostly seen things working correctly, but for robotics, we need to accurately model what happens when the robot makes mistakes, when it drops objects or fails to grasp them, when plans go wrong. This ability to simulate counterfactual actions, what would have happened if the robot did something different, is an area we are particularly focused on. Which brings us to one of the applications of GWM Robotics we're really excited about: policy evaluation. This means you can test how well efficient language action policy or other models will work before you ever run it on hardware. You can also use GWM Robotics to create synthetic data or to create new variants of existing videos and significantly grow the size and diversity of your training data. We also hope that this opens robotics research to research teams that have no hardware at all, allowing them to push the frontier forward without needing the immense resources that the hardware requires.
Thank you, Rick. This work is just beginning. We're also releasing a development platform so robotics labs, enterprises, and academic researchers can try the models themselves. GWM Robotics will be available soon via our API. Let's take a look at how this research works.
We took our state-of-the-art general world model, GWM1, and built a novel approach to training in robotics. GWM Robotics is a new frontier for video simulation. It bridges mere representations of the world with the ability to actually interact with it. Where traditional training is expensive and slow, our general world model approach is much more flexible and scalable. Designed to perform various real-world tasks, from robot policy evaluations to synthetic data generation. The model demonstrates strong action adherence, accurate motion, and realistic object interactions. We are currently collaborating with a number of robotic labs, integrating GWM Robotics into their training via our SDK. If you're interested in learning more about GWM Robotics, visit runwayml.com.
We believe that general world models will play a very critical role for the future of AI. And we think that giving everyone access to their own world simulator will be one of the most important technological deployments of the next few years. Those simulators will only become more general over time. Today, they're only trained on human-scale video, but we do have some early indications that GWM1 and the models that will come after it can be applied to observations from very different scales of space and time. And they will help drive progress in physics, in life sciences, in biology. With world models, the aim is to run virtual experiments much faster than we ever could in physical reality. And in this way, we can accelerate scientific discovery. Over the coming weeks, we'll be releasing a lot of these models in our web product and API. Treat them as early prototypes, as glimpses of this future that comes with world models. There will be glitches and consistency issues. Things will not be perfect. But the models will improve rapidly. That's something we've seen with every past generation model as well. And we truly believe that incremental deployment of those models is critical. It's how people come to understand how the technology works and where it's going. And it's how we, as model developers, learn how to build those models responsibly. Training world models demands very large-scale compute, potentially beyond what's needed for language models. So we're rapidly scaling our infrastructure over the next year. As part of that, we've signed a new partnership with CoreWeave to build a large-scale training cluster dedicated entirely to scaling world models. That cluster is built in close collaboration with our friends at NVIDIA. This infrastructure will be the foundation of this next generation of AI that simulates everything. We spent the past 7 years building this new strange kind of company at the intersection of art and science. But we believe that we're still at the very beginning. And so, to wrap this up, let's get a quick summary of everything we just announced from someone I'm sure you all know.
Runway is one of the world's first generative AI companies. Today, Runway is announcing a whole new family of world models. These are long context, long sequence, long horizon models, and it stays temporally and spatially coherent. One of the most amazing things about it is real-time interactive video. It's almost like computer graphics, except it's completely generated by AI. They have a unified environment that could be used for content creation and video games and avatars.
Hello there. It's nice to chat with you. Ask me your questions.
And one of the new and really exciting growth opportunities, physical AI robotics. This is just an incredibly exciting announcement